Hello everyone, welcome you all again to my channel Techno Tutorial. So in today's topic we are going to discuss about recursion. From your syllabus we have completed some of the topics from first unit. Almost we have completed. So here recursion topic we have not covered till now. So we are going to discuss recursion today. Here some topics it has given in recursion simple algorithm which recursion print a message forever. So that is using recursive function you have to do this program. Sum of first n numbers you have to display by using recursion method. So here factorial also you have to do Fibonacci series, recursion of on arrays, binary search. So these are the programs it has given. So I have done all these programs practically so that you can directly practice from these programs. So you have to know about the recursion. So all these programs I will send you on mail so that you can practice. So these programs I have done for you. So I will send you in a zip folder on mail so you can download and practice. If you have any doubt then you can ask me. And for all the topics, all other topics which are given in your syllabus, so all these topics, the video links I have given, all videos description part, so directly you can access any your required topic from that description YouTube link. Okay, so now here about recursion, it has given recursion means, see, when the same function call itself, it is known as recursion. So about recursion, see, I have prepared this presentation for you. Recursion is a process in which a function calls itself as a subroutine that allows the function to be repeated several times since it calls itself during its execution. Functions that incorporate recursion are called recursive function. The meaning is, suppose you are calling a function. So about function already you have done. So how to call a function you know. Okay, in previous programs already you have completed the function part. So suppose you have called a function name is factorial, so that your program directly it will redirect to the function definition part. So there it will execute the executable codes which are given in the function definition part. Okay, so in a function concept you know already the function call is there, function definition is there, function body is there, parameter list is there. So when you will call the particular function by giving the function name, suppose factorial, and you are passing a parameter from that function call part, suppose you are sending 5, so that 5 will go to the function definition part, and there you have to take a variable where that value it will store for the execution. Okay, so that value it will store during the execution of the program. So for that one variable you have take. Okay, so that is argument you can say. So inside that function, suppose in the function definition part factorial, in the definition part again the same function you are calling. That means inside the function again the same function you are calling. So that is known as recursion. So practically when you will see the program then you will understand clearly. Okay, so now recursion is often seen as an efficient method of programming since it requires the least amount of code to perform the necessary functions. That means least amount of code you have to write. When you will call the function, it will automatically redirect to that particular part. So no need to write more lines for the execution of a program. However, recursion must be incorporated carefully since it can lead to an infinite loop if no condition is met that will terminate the function. Okay, it may be infinite loop if your condition is not there clearly. So see, let's go for practice. So here these are the programs that I prepared for you so that you can from your syllabus so that you can practice these programs. So I'm going to show you, suppose this program, sum of n natural numbers. Okay, using recursive function. So now see, so here see already how to define a function you have done. By using def keyword you can define a function. Def sum, that means your function name is sum. So where is this function? You have called this function from here, then only it will go to this function part. So now see what you have done, from where your program have to start. From this line you have to start your program, because this defined function, this function you have done, but this function will not execute until you will call this function. Clear? So when you will call this function, then only this function will execute. Already you know. So now see, from where you are calling this function, from this line you are calling this function, then only this function will execute. Before that, in the main function, in the main program, this line is there. This is the first line here in your program. So what you are doing here, input, enter a number. So this number you are entering, suppose 5 here in n, the value of n is suppose 5, not 5, suppose 3. Okay, 3 is your entered number. Now s is equal to sum n, that means you are calling this sum function by passing this the value of n. The value of n is 3. This is the parameter what you are sending. This is function call. When you will call this function, then where your program will go? Your program will redirect to this function definition part. Clear? You have defined this function here, define def sum. So in this variable, it will store the value which you are sending from this function call part. That means you are sending 5 from here. This 5 will store here in n. Suppose you are sending 3. This 3 is there in n. If your condition, what you are doing, see what about recursion? See this sum, inside this sum you are calling this function again. That is known as recursive function. It is clear? So recursion, this technique is known as recursion, and this function is known as recursive function. It is clear? So now see, inside this sum, inside this definition part, you are calling the same function again. That is why it is known as recursive function, and this technique is known as recursion. Clear? So now see, if n equal to 0, your entered value is 3 here, not 0. So this condition is false. That means it will go to the else part. Return, it will return a value. So what it will return? N plus the value of n is what? 3. Okay, 3 plus sum n minus 1. That means 3 plus, you are calling this function. See, 3 plus sum n minus 1. That means you are again calling the sum function. So what it will add? Sum n minus 1. N minus 1 means the value of n minus 1 is what? 3 minus 1. What? 2. That means 3 plus 2 it will call. That means when you will call this function, then automatically this will redirect to this part. So it will come again here. This condition is false because this value is 2 now. So return n plus 2 here. Again you are calling sum n minus 1. Like this will execute again and again. So this time n plus 2 means 3 plus 2, this is 5. Here the value of n is 5 this time. Okay. Again here 2 minus 1. Again you are calling this function. Again you are calling this function. 2 minus 1 this time, not 3 minus 1. So this time when you are calling this function, you are passing the value here 1. 2 minus 1, 1. Then again it will go here. Again it will say here 1 equal to 0. Condition is false. So again it will come here. This was already 5. 5 plus 1, 6. Clear? Now n minus, again you are calling this function. So this is 1 minus 1, 0. So the value of n is already 6. So 0. This time you are sending sum 0. So this 0 will go here into the value of n. So now if 0 equal to 0, condition true, return 0. Clear? So what is the value of n? The value of n is 6 already. And this function is finished. Okay, after 0 it will not again go to the called function function definition part. So here it will return the value of n is 6 because this function already returned 6. This 6 will store here in s. Print the sum of natural numbers up to n. Up to n means what? 3. Up to 3 is 6. S means 6. Now if you run this program, it will come the sum of natural numbers up to 3 is 6. Now run this program, press F5, enter a number. We are entering 3, enter 6. The sum of natural numbers up to 3 is 6. It is clear? Now again if you are going to do this program, I am going to run this program again. So I am entering the number here, suppose 5. Then what will come? 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. Okay, and press enter. See, the sum of natural numbers up to 5 is 15. Clear? Okay, so I think you have understood this topic, this logic. how this program has done, and what about the recursive function, and what about the recursion. Clear? So similarly, I have prepared from your syllabus these other programs. So this is suppose factorial. This is factorial. See, you are calling this function factorial, and you are passing one value from here. And when you will go to this function definition part, inside function definition part, again the same function you are calling. Clear? So this technique is recursion, and this function is recursive function. Clear? So factorial means already you know what is factorial. Factorial means when you are entering a value, suppose 5, so it will add the values up to 5, that means 1 to 5. That is 5 plus 4 plus 3 plus 2 into multiply, it will multiply, not add. 5 into 4 into 3 into 2 into 1, that is the factorial value. If you are entering the value suppose 10, that means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So what the exact value it will come, it will display. So that is the factorial. Okay, so now here see how I have done this program. And one value you have entered here, suppose the 5 you have entered here, suppose okay 5 you have entered here, the value of n. Print factorial, okay, it will display, just only display purpose. Print factorial n, here it will display the result. So when you will call this function, it will execute this program, this function, then it will return a value. This value it will display here, because in print option this value is there. Clear? So you are sending factorial n, that means you are passing value 5 from here. So this 5 will go here. Okay, so if 5 less than equal to 1, then it will return 1. Clear? So up to 1 it will calculate only, else it will do this function. See, return similar to the previous program. Here the value of n is 5 into factorial n minus 1. Again you are calling this function, then this will go here. What value it has come here in n? N minus 1. N minus 1 means 5 minus 1 4. So the value of here n is 4. Condition is false, it will come here. 5 into 4 means 20. Again this function is calling factorial n minus 1. 4 minus 1, then it will go here. Clear? 3. So already 20 was there. 20 into 3, 60. Again you are calling this function. So like that up to 1 it will call this function. So you will get the value 120. Clear? I think you have understand the logic. So if you run this program, I am entering the value 5 here, factorial 120. Clear? So in the previous program you have done addition, sum, and here in this program you are doing multiplication. Clear? So factorial is done. Now this is another factorial. Same logic I have given, I think. Okay, by using comments I have given this program. The same logic it has used. Okay, you can see from here. Try to understand. One other way I have given that given the program. Next here say Fibonacci without recursion. So Fibonacci series. So you have to know about the Fibonacci. So this was also your topic. In Fibonacci series means see what it will display. When the value 0 plus 1, what will come? 1. 1 plus 2, then 3. 3 plus 2, then 5. 5 plus 3, 8. 8 plus 5, 13. So like that it will come, the values. Okay. So now here see without using recursion, just see the program, how the output it will come, what the output it will come. So see what is coming. Enter a number. I am entering 5. Enter. So 5 numbers are coming. 1, 2, 3, 4, 5 numbers are coming. So how the numbers are coming? 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. Like that is coming. Clear? So now again the same program I am going to run. Here I am giving the number this time. This is 10 suppose. So 10 numbers it will come. So 10 numbers is coming. So here 0 plus 1, 1. 1 plus 1, 2. 2 plus 3, 5. Clear? 2 plus 1, 3. 3 plus 5, 8. 8 plus 5, 13. 13 plus 8, 21. 21 plus 13, 34. Like these values are coming. So how logically this program has done? So you have to understand. So this is actually not recursive function. So in normal method I am going to show you how actually Fibonacci has done. After that this program I am going to show you in recursion. A and B variable I have taken. So in these two variable I have already assigned two values 0 and 1. Clear? N equal to integer input, enter a number. So you are entering a number, suppose 5, 10, 11, 12, what number you want to enter. Suppose next print 0. These two numbers I am going to print directly, not logically. See, in logic, these two numbers I am not giving. Directly I am displaying 0 plus 1, 0, 1. After that, for I, that means loop it is using, I in range n minus 2. If your entered number is suppose 5, then n minus 2 means up to 3 it will go. Clear? Why n minus 2? Because these two numbers already I have taken. Clear? So now up to 3, your range is 3. Range is 3 means 0 to 2, 0, 1, 2. Clear? So it will start from here. So what is the value of I for the first time? This is 0. And this is, if it is your value, if your entered number is 5, then 5 minus 2, 3 is the last number here. That means 0 to 2 it will go. 0, 1, 2. Only 3 numbers are there. So here I value is 0. C equal to A plus B. That means 0 plus 1. 0 plus 1, 1. The value of C is 1. Print C, 1 it will display. Already it has displayed 0 and 1. After that, 1 it will display. After that, A is equal to B, B is equal to C. You are doing swapping here. B's value you are assigning to A and C's value you are assigning to B. Clear? Clear? Swap program already you have done. Now see, what is the value of A? 0. What is the value of B? 1. Now this time what you have done, A is equal to B means B's value was 1. 1 you are assigning to A, now the value of A is 1. Clear? And B's value you are assigning C. That means C's value was what? A plus B was 0 plus 1, 1. Then B value is 1, A value is 1. It is clear? So now again when this program will, this is a loop. When again this time it is come, so next time the value of I is 1. It is clear? So now see, C is equal to A plus B. That means 1 plus 1, 2. Clear? Print C, 2 it will display. Clear? So see this output. Suppose this the entered value is 3 or 5. Entered value is 5. Now here see what it has given. For the first time this 0 and 1, this 0 and 1 directly displaying. After that 0 plus 1, 1, C's value is 1. This C's value you are assigning to B. C's value is 1. Now print C. That means this 1 is coming. Clear? Now again A's value is 1 now. B's value is 1. Again this loop will execute. Here the value of I is this time 1 because this loop has increased. So now C is equal to 1 plus 1. A and B's value is 1 now. Then C's value is 2. Print C. So this 2 is coming. It's clear? Now go to the next line. A is equal to B. So what was the B's value? B's value was 1. So A value is 1 now. And B is equal to C. What is the C's value now? 2. So this 2, C's 2 value we are assigning to B. Now again here I am going, now this time the value of I is 2. So this loop has finished now because n minus 1 was there. That means 5 minus 2 means 3. That means it will go to 0 to 3 or 0 to 2. Yes, 3 means n minus 1, 0 to 2. So this is 2. This is last time executing. C is equal to A plus B. So A plus B means A value is 1, B value is 2. Now 1 plus 2, 3. Print C. 3 it is displaying. Clear? So like this I have done this program without using recursive function. Clear? So now this is the same program I am going to show you using recursive function. This is the Fibonacci series using recursive function. This one. So here this program has done like this. Similarly what you have done for factorial and sum. So the same function you are calling again and again. So how you are calling, how it is executing, try to understand by yourself this program. Okay. About Fibonacci series I told you. About recursion, about recursive function I told you how to execute. Okay. So now similarly this program, see this recursive recurfivo you are using the function here. This recurfivo function it is calling 2 times recurfivo. Clear? So how logically it has done, that means inside this recursive function you are calling the same function. That is why this is known as recursive function, you know. This is recursion, you know. So how this program has done, try to understand by yourself. If you have any doubt, then you can ask me and I will tell you. So you have to think by yourself, then only you can understand the logic clearly. Okay. Okay, next 2 programs also I have given here, binary search. is also there. So about binary search I am going to tell you, but how logically it has done, you have to try to understand. If you have any doubt, then ask me, then I will tell you. Okay. So now see about binary search. See, binary search means when you are entered an array, one sorted array you have to take. This is the sorted array. Sorted array means already in ascending order. It is clear. So binary search program already you have always you have to do in a sorted array. This in this array some elements are already given there. That means see 2, 3, 4, 10, 40. These elements already given into this list array variable. So here binary search means you are going to search any of the number. Suppose 10 you are going to search where it is, in which position it is, 0, 1, 2, 3 in third position. That means it will show in fourth position. Okay, because 0, see where what you will tell. Suppose where is 10, directly you will tell that 1, 2, 3, 4 in fourth position 10 is there. Yes or not? So now see, I'm going to run this program. Suppose what it will come. Element is present at index 3. So which index it is searching? Okay, 10 is searching. Or 10 is searching. It is showing 3. 0, 1, 2, 3 in third position. So actually some of the programs I got that there it has written index plus 1 it is showing. Why? Because see in which position 10 is there. So directly without the logic behind it, that means 0, 1, 2, 3, directly what you will say 1, 2, 3, 4 in fourth position 10 is there. So that is why for so in the print option it will display 4. Suppose in fourth position it is there. Okay, so now actually here it is showing the logically, so no problem. So you are searching 10 in 10 is where in which position of this array 10 is there in 0, 1, 2, 3 in third index. So it is showing that. So that is the binary, that is searching. So binary search technique means this is it will take as start and this it will take as stop. Start plus stop it will add. That means start index is what? 0 and stop index is what? 0, 1, 2, 3, 4. Clear? 0 plus 4 what? 4. And it will divide by 2. That means your middle is what? 2. 0, 1, 2. This is the middle position. 0, 1, 2. How it will get the middle position? Because it will take start value and end value and divide by 2. Clear? So divide by 2 means it will get the middle position. So now the binary search technique is it will find the middle position first, then it will check your searching element. Suppose 10 is your searching element. Searching element is there in the middle position, then it will show that your item is found in the position number this. Clear? If your item is not there in the middle, suppose your item is here in the right side of the middle, that means it will add start value start plus 1. That means a middle plus 1. Your start value will change for this time. That means your start was this. Your start was this. Oh, sorry, this. And this is middle. So your start will which one? Your start will for if your searching number is 10, which is greater than middle. Array middle. Your middle is this. Your searching element is greater than this. So now it will change the start position. Start position was this. Now this time your start position is 0, 1, 2 plus 1. That means middle plus 1. That means 3 is your start position next time. Clear? And again the same logic you have to use. N this 4. 3 plus 4 divided by 2, 7. That means 7. 7 divided by 2. 3 plus 4, 7. 7 divided by 2. That means what it will come? 3.5. So it will take 3. Again it will take 3. 0.5 it will not take. Then your start is already 3 and middle is also 3. So now this time again it will check your entered number is where? Now your entered number is the middle. Middle is also 3. See, this is 3. 0, 1, 2, 3. And start is also 3. End is 4. So if your entered number is in the middle position, then your item is found in the position number this. This is the logic. if your search item is less than middle part, that means your search item is this, suppose, then it will change the end value. If your item is greater than middle part, then it will change the start value. And if your search item is less than middle, then it will change the stop. That means your suppose search item is 3. This time what it will do? Then it will do logically, this was start 0 and this was end stop. That means 4 start plus end, 0 plus 4 2, 0 plus 4 divided by 2, that means 2 your middle, this was the middle, clear. 3 is not there in the middle, that means again it will check. Again where it will check? It will check here, see, this is start and your item is less than middle, then stop value will -1. And if it is greater than middle, then it is end +1 and stop here is less than, that means stop -1. Here start is 0 and stop is 2 minus 1. 0 1 2, 2 minus 1, this is 1, middle is 1 this time, stop is 1, 0 plus 1 1 divided by 2, so what it will take? It will take 0.5 has to come actually, so it will take 1, so middle is 1 and stop is also 1, then it will show your result here. So this is actual logic of the binary search. So how practically, logically how it has done, try to understand. How the program it has done, try to understand. Okay. If you have any doubt, then you will ask me. See here, you are calling this function binary search. You are calling this function binary search. This function. So you are passing these values ARR. This value you are passing 0. You are passing one value. And len array, you are calculating the length of this array, and that value -1 you are sending from here, and x your search item. So everything it will send to here in this function part. Here in binary search, again you are calling this binary search function. That means this is recursion or recursive function. So try to understand the logic, how it has done. If you have any doubt, then you can ask me. Okay, this was the topic in recursion. So already I have completed. So this program you have to practice clearly by your own at home. Then only you will understand the logic, what it has done, how it has done, what about the recursion and the recursive function. Okay, then this topic we have finished. So first chapter almost we have finished, almost means we have finished I think. So see what about which one is left. Data structure already we have done. Idea of efficiency, this topic has not done idea of efficiency, so I will start this topic. So after that recursion already finished. Using Python libraries done. So using Python libraries since we have done, that means in next topic I will try to show you about the project, what you have to submit in practical in board exam. So let's see what I will do. So after that this file handling also we have done, and functions already we have completed. So unit 1 almost we have completed. Next unit 2 we have to start. Okay, so till now if you have any doubt, then you can ask me, and all videos links are there in the description part. You can see from that YouTube description. If you have any doubt, then you can ask me. Okay, thank you, bye bye.